on this first rule so far. There were also two other rules that we talked about. We said, I know something is not simplified if these two things are true, or one of these two things are true, but we haven't actually talked about how to fix those two things if we see them. Those two rules, and they're on your blue sheets, or at least they should be. The second one is, there is not a fraction inside the radicand, or the radicand is not a fraction. We're going to focus on this one first today. And then the second one that we're going to focus on today is, there is no radical in the denominator of a fraction. Now we are going to look at both of those rules today. Okay. The way that these notes are set up is that they are in order of the steps that you should do when we see division problems with our radicals. All of these things we're going to do are division problems. The first thing that we can do with a division problem is this division property of square roots. This is also in your note on your blue sheet. It says that if I have the square root of a fraction, which we know based on rule number 2 is a no-no, we cannot have the square root of a fraction, then I can rewrite the square root of a fraction as two separate radicals, the square root of the top over the square root of the bottom. This is going to come in handy for us because it is much easier for us to simplify whole numbers than it is to simplify fractions. So this is the first thing we should always look out for. If I take a look at letter A, there it is. If I take a look at letter A, I know that this fraction cannot be simplified the way that it is. 9 and 49 do not simplify, but I can rewrite it as the square root of 9 over the square root of 49. Both of those numbers now by themselves are easy for me to square root. The square root of 9 we know is 3, and the square root of 49 we know is 7. So 3 over 7 would be our final answer there. Any questions on that? Same thing with letter B. If I take a look at letter B, I have 4x squared over 81, which is not a fraction that I can simplify. But if I break it into two separate problems, 4x to the second and the square root of 81, hopefully now I should see that I can simplify. What's the easiest thing for me to simplify in this problem? The top or the bottom? The bottom. The bottom simplifies to what? Perfect. The square root of 81 is 9. What about the top? 4x squared. 4 is a perfect square. 4 can become a 2 on the outside. And then what about x squared? What's our rules for variables with exponents? James? We're going to take that even numbered exponent. We're going to divide it by 2. X to the second divided by 2 is x to the first. It goes to the outside. There should be no radical left. Good? This is simplified. It meets all of my criteria. There's no perfect squares left. The radicand is not a fraction. There's no radical left in the bottom. Let's look at the last one. Is that the wind or is that my door? Okay. So, once again, 32x to the third over 25 is not a fraction that we can simplify. So instead, I'm going to split them into two pieces. The top, that's a third, and the bottom. What's the easiest part for me to simplify? The bottom, which becomes what? 5. Beautiful. Okay, are there any perfect squares up at the top already? Not yet, but we know that we can split that up. Let's start with a 32. 32 I know can split into 16 times 2. We're going to take care of that in a second. What about that x to the third? Do we remember how to split that up? It's not even, so what do we have to do, Cody? We're going to take away 1. We're not getting rid of it. We're just going to put it off to the side. So it's still there. Now here's my perfect squares. 16 is a perfect square. That becomes a 4 on the outside. And then x squared, even number, that's a perfect square. We're going to divide by 2, which gives me an x to the first. That goes away. What's left on the inside is a 2x. And then the bottom is a 5. It meets all of my criteria. There are no perfect squares left in that radical. There are no fractions inside of a radical. And the bottom of that fraction has no radicals. Yes? Everybody sees that? This is our first step. We should be trying to do this every single time if possible, is to split these fractions up into the top and the bottom and simplify them separately. It's the easiest way to go. Sometimes we have an extra step in there first. Sometimes they can be reduced first, which means if I take a look at something like this, the square root of 18 over 2, can we simplify that fraction first? What does that fraction simplify to? Perfect. So instead of saying the square root of 18 over 2, I'm going to write this as the square root of 9. What is the square root of 9? Look at how nice and easy that one was, because we could simplify it first. Good? What about this guy? If I have something on the inside of a radical on the top and something on the inside of the radical on the bottom, we can simplify them together just like fractions. I cannot do one on the outside, one on the inside though. These are both on the inside. It's like if I rewrote this as 24 over 2 inside the radical. What is 24 over 2? 12. Is that simplified all the way? No, I still need to split it up. I can split that into 4 and 3. We've done this one a million times, so I'll kind of go through it quickly. 4 becomes a 2, and we got a 3 left over. Good? Yes? Yes. Okay. Weird one in here. Are you ready for all these steps? Okay. I'm going to put this all back together first. It's like the opposite of what we were doing in the first section. Instead of splitting this into 2 separate things, I'm going to squish them back together to be one radical. So this radical is 48x to the 7th over 6x. They simplify kind of nicely. 48 over 6 simplifies to what? What is this? 48 over 6? 8. Perfect. Okay, here's something we haven't talked about in a minute. If I have x to the 7th over x, do we remember how we simplify these variables with their exponents? We're going to subtract them. So this is like x to the 7th minus 1, which leaves me with an x to the 6th. Now, all of that is still inside that radical. I haven't done anything to take them out yet. Is everybody okay with that step? Okay. Now it should just be regular simplifying like we've done a million times before. I'm going to separate that 8 into 4 and 2. Oops. Hello? 4 and 2. And I'm going to separate that 6. Oh, do I need to separate that 6? What can I do with that x to the 6th? We're just going to divide it by 2. It's an even number. So that becomes an x to the 3rd on the outside. This 4 is my perfect square. So this should be 2x to the 3rd square root 2. Any questions on this? Am I going too fast? I'm adding more rules. I'm not stopping adding more rules. I got a bunch more. Are we good with this? Okay, flip it over. Back page. So far what we've done, if we take a look at all of the answers that we've done so far, you should be looking at the back page. But if you take a look at all these answers we've done so far, look at how they all come out nicely. All of those denominators come out to nice whole numbers. We haven't had to worry about that third rule yet. That third rule is that we cannot have a radical left in the denominator. We're going to address that rule right now. We are still going to go through all the steps as normal. The same steps that we've done so far, split it if we can, reduce it if we can. But sometimes that still will not get us perfect square, or that will not get rid of the perfect squares in the denominator. In these situations, we are going to learn a new vocab word. It is called rationalizing. we are going to rationalize the denominator in order to satisfy that third criteria, that third rule. The fancy way to say rationalize is to say we multiply the numerator and denominator by the radical that would make the denominator a perfect square. It's really not as complicated as that sounds. I'm going to show you what it looks like first. But the rule that we should always be following to make our lives easier is to always look to reduce first if possible. Okay, are you ready to look at the examples? I'm going to take a look at this one, radical 3 over radical 7. I want to reduce this. I want to make my life easy. So the first thing I'm going to do is write them together. Does 3 over 7 reduce at all? Unfortunately, for me, it does not reduce. So I have to go to my strategy called rationalizing. That's not going to work. So instead, I want to make that bottom, the denominator, a nice whole number. Do we remember what we can multiply radical 7 by to make it just a 7 to get rid of that radical? If I multiply it by itself, I get rid of that denominator, of that, of the radical. I'm going to write this out for you. If I multiply that radical 7 by itself, by radical 7, I get square root of 49, which we know makes 7. Yes? That's perfect. That's exactly what I want. My square root is now gone. However, in math, we cannot do something to the bottom of the fraction without also doing it to the top of the fraction. So I need to multiply by radical 7 not only on the bottom, but also on the top. So the square root of 3 times the square root of 7 is equal to the square root of 21. And can 21 be simplified down at all? It cannot. So my answer is the square root of 21 over 7. It meets all three of my rules. There are no perfect squares left inside that 21. The radical does not have a fraction on the inside. And the bottom of my fraction is no longer a radical. Any questions on that right now? Okay, we're going to do some more. Take a look at B. Currently, as it stands, the insides of these radicals, the 5 over the 6, those cannot be simplified at all. 5 over 6 does not simplify down any further. So I need to rationalize. What are we going to multiply by in order to make that radical 6 a whole number? I'm going to multiply by itself, by radical 6. What I do to the bottom, I'm also doing to the top. So this is essentially like multiplying by 1, right? I could write 1 as 3 over 3, and it's still 1. I can write 1 as radical 6 over radical 6. It's still 1. So I'm not changing the value. I'm just changing how it looks here. So the bottom, I multiply radical 6 by radical 6. Now what do I have left in the bottom? The radical 36, which simplifies to 6. That's my goal, is to get rid of that square root. On the top, 2 radical 5 times radical 6. Our multiplication rules from Friday are that outsides go together, insides go together. On the outside is a 2. On the inside, 5 times 6 makes 30. Any questions right now? Okay, let's go through my rules. The first rule, are there any perfect squares left inside of a radical? Can we take anything out of that 30? No. Is there a fraction inside of that radical? No. Is there a radical left in the denominator, in the bottom? No. All three of my rules are met. However, there is one thing that I can still do to this. Remember what I told you, we always want to reduce. Things on the inside of radicals can reduce. Things on the outside of radicals can also reduce. So 2 and 6 are both on the outside. We can reduce it just like a fraction. What is 2 over 6 in its most simple form? 1/3. So we are going to rewrite this. You don't have to write the 1. I'm going to write the 1 just so we see where it comes from. Oh, not 1/6, 1/3, sorry. You do need to reduce it all the way. You do not have to write the 1. So if you wrote this, I would accept this. But if you do not write that, if you leave it as 2 over 6, you will get points taken off because you're not simplified all the way. improper fractions can still be reduced. So if you had 9 over 6, I would still expect to see this written as 3 over 2. Good question. Other questions on that? Okay. I know, this feels like a lot. Let's take a look at C. We always want to reduce first. Things on the inside of a radical can reduce with each other. Things on the outside of a radical can reduce with each other. There's only one radical, so that can't be reduced. But this 8 over 6, can that be reduced? What does that reduce to? We just talked about this. 4 over 3. We can divide both things by 2. So let's rewrite this as 4 over 3. That radical 10 has just got to hang out there. Okay, this does not meet all 3 of my criteria. There is still a radical in the bottom of this fraction. So I still need to rationalize. I'm going to get rid of that radical 10 by multiplying it by what? By radical 10. What I do to the bottom, I have to do to the top. So let's look at the top. On the top, 4 times radical 10 is 4 radical 10. And then on the bottom, I have 3 times, what's radical 10 times radical 10? Just a 10. Perfect. So this simplifies to 4 radical 10 over 30. Am I done? What do you think? Why no? Because I can simplify 4 over 30 into 2 radical 10 over 15. Perfect. This is a lot of steps. Is everybody still keeping up? One more, like this. Okay, what should I do first here? Can I do something else first? What can I reduce those insides to? Perfect. Okay, I reduce the insides. It makes my life a little bit easier. Then what can I do? Am I done here? What do I still have to do? Beautiful. So this is on the top, radical, and on the bottom? Is that simplified? Yes, this one is. Okay, one last one. Creed from the office is doing some algebra. He's simplifying this radical expression. His answer is correct, but there was a much more efficient way to go here. What could he have done first instead? The 10 and the 2 are a fraction. They're both on the inside. So I could rewrite this as 10 over 2 inside, which we know reduces to 5. Isn't that what he got, but just like 4 steps sooner? Yeah? Okay. Any questions on this?